ESF is the oldest, largest, and most distinguished institution in the United States that is focused on the study of natural resources and the environment. Hello and welcome to this edition of Improve Your World with SUNY ESF. I'm Dave White. Our subject today is a climate change landscape. It's located here at the Syracuse University Life Science Complex, an innovative idea with a humble beginning.
Well, my colleague, Jason Fridley, who is a plant ecologist in the biology department at SUNY, we're good friends, and we collaborate on projects, and we go out for coffee every so often. And so Jason and I were walking across campus, and it was before the landscaping had started, or it was just starting, and plans were set into motion at least. And we, on our way to coffee and coming back, we talked about how we were missing an potential opportunity. We could the original plans for landscaping was to include just a handful of introduced trees that looked nice around the building, life sciences. And Jason and I thought that it might be a really great teaching opportunity if we could select some of the trees and shrubs that were going in, increase the diversity, and handpick the trees to represent trees that have distributions in different climate zones around the country. So that's how it started, and we went to our chair, who thought it was a great idea, and the chair had a meeting with the provost, Eric Spina, and Eric thought it was a great idea, and from that point on it really started rolling. It required cooperation with the landscape architect as well, who had thought probably that his design was done and he was probably on the next project, but he had to come back and discuss with us the tree options, the tree species options. And so it was a really beautiful collaboration across campus that included the landscape architectural firm, including administration, grassroots from the biology department. Folks at ESF, Don Leopold in particular, helped us tremendously with the species selection, the tree species and shrub species selection, and the grounds folks at SU who really pushed this. So it was a terrific joining of forces that allowed this to happen.
What makes the makeup of what you planted so unique?
Well, it is a unique facility, on-campus facility, and I'm just getting shivers just thinking about it. The opportunities it will have over the years for undergraduate education. What we have done is we've selected 33 tree and shrub species, and these represent common species in central New York like sugar maple, white oak, American beech. And paired with these species are related species from other climate zones, as I mentioned, so areas that are drier, wetter, warmer, colder. And over time, we're going to be able to monitor how our changing climate here in central New York is influencing these important components of our forest ecosystems. So our idea is that it's a long-term experiment, and it is an experiment because it's a fully replicated experiment, and we'll be able to, through coursework, through courses on climate change and forest ecology, plant ecology, we'll have undergraduates monitoring the growth and vitality and a number of physiological traits of these trees as our climate changes. We're still looking for funding. Hopefully we'll be able to get that, but the idea is that we'll mount cameras on buildings that are looking down upon the garden, and will over years monitor leaf out and senescence of all these different species, and see how, this is an example of how we can use the garden, see how that changes over time. This information will be archived so that undergraduates who are taking biology courses or ESF courses or courses across the country will be able to go back to 2014 and compare it with the current year of 2020 and see how it's changed. We're hoping to instrument the trees so that there'll be real-time data collected on traits like evapotranspiration, which is associated with growth and photosynthesis, and that will be automatically downloaded to a website and archived. So the really wonderful thing, I think, about this facility is that it's on campus. It's just a few hundred feet from our classroom, so we can talk about certain ecological processes one half hour, and in a matter of moments be out collecting information on a large variety of trees and shrubs that represent important components of these ecosystems around the country, and then come back to the laboratory and talk about those data.
When you look at a lot of very good landscape designs, they're designed mostly for looks, not for practical application.
Yeah, I agree, and maybe this can be used as a model on other campuses by other landscape architectural firms. I'm not a landscape architect, but this is real dual use, and it's going to really improve dramatically our ability on the Hill, both campuses, to talk, to teach, for students to understand the consequences of global warming and climate change. It will really drive in the message.
Where are some of the unusual trees coming from?
Well, they're coming. It depends on the group. So we have groups of, for example, fir, a number of species of maple, a number of species of oak and pine. So, for example, oak, we have our local representative would be white oak. Our western representative, which is warmer, would be shingle oak, and our southern representative is Shumard's oak, and that's an oak that occurs in the deep south. That's one example, so it depends. There's some, for example, pines may occur further west in the Rocky Mountain West, our western component, which would be warmer and drier, compared to pines, our local pines here. So it really depends on the group, the genus of trees and shrubs that you're speaking of.
How do you think they're going to fare?
I think it's going to get warmer here, and we have seen that recently over the last couple of decades. Whether or not it gets wetter, it may get in our snowbelt lake effect area. It might, over the winter at least, it might get wetter. So it will really depend on if it gets drier or wetter, I suppose. I mean, that's why we're conducting this experiment. Things are going to change. I suspect that the health and vitality of our local representatives will decline over time, and certain other tree species from other parts of the country might show an improvement. We'll see. We'll see what happens. But that's really, I mean, we're conducting a scientific experiment, and that's part of the excitement of this whole enterprise, because we don't know the outcome, and the students will be able to discover it as we, the instructors, will be helping them analyze the data, and they'll be the ones that will be discovering it on their own.
From what you're describing, it looks like you're going to be collecting a huge amount of data.
That's true, and we have, with the number of students that are going through our courses, we have the opportunity to do that. The garden will be used in a number of courses, for example, related to climate change courses, the effect of global change on global world forest ecosystems. The garden can play an important role in that course, and collecting data on these species can play and be an important component of that course. But we have ecosystem courses, other plant ecology courses. We have such a wide variety of plants that are growing in the garden that we can talk about how do the attributes to the plant traits of change over the course of succession, which is how a forest develops after a major disturbance. And we have early succession trees from central New York and very late succession trees from central New York. So we can read articles about what others have found, and we can go out in the garden and we can check their data and see if that's occurring in our garden as well.
Because things will change as it grows when as the canopies, if they're successful, as the canopies expand, it'll change the amount of sunlight that plants underneath are receiving, that type of thing.
Yeah, that's true. We're only interested in the trees themselves, but you're absolutely right. The traits will change as plants get older, and all these plants are, they're getting older at the same rate. They're planted at the same time. Hopefully, we'll be successful. All the plants will survive, and we'll replace those that don't, of course. But there'll be these long-term data are there's not a confounding factor of tree age, at least. Mm-hmm. There'll be different sizes because some trees will grow bigger than others.
Right. But it won't be like going into the forest and there'll be all different ages, and it's hard to you end up making a comparison of apples to oranges.
Yeah, that's true. It's a very controlled, in that sense, it's a controlled experiment. But it would be important, and it would be great if we could go to a field site and check the results our results from the garden, compare those results for local species, at least, that are growing in central New York, and see if the same thing is occurring in the field. So start a long-term study at a field site as well, and that would be an important component of a course on forest ecosystems that we hope to design and start very soon.
Well, ESF has about 25,000 acres they might be able to share.
That's right, and I'm hoping for that. And we're also talking to the state park system. They have a new program called Forces that we're hoping for at Green Lakes. They're going to be able to set aside a site where we can take students out, and it's a long-term safe site where experiments won't be tampered, and we can use that over the long term as well.
Mm. Okay. Now, we were talking earlier, you said that your area of specialty was
grasslands. Yeah.
So how do you go from grasslands to trees?
Well, if you're interested in plants, trees are just big grasses.
Back to the garden here.
Yep.
A thought just occurred to me that because you're collecting the data that you're hoping to use to make long-term conclusions, is there anything special you need to do about maintaining the area?
Yeah, we hope, again, this depends on funding, so if anybody out there listening has some deep pockets, but we hope to be able to find some funds to hire a full-time technician who will be maintaining the garden and taking part in a lot of the laboratory experiments, acting as a teaching assistant, in essence, for the courses that are going to be using the garden. We've talked to the physical plant to try and reduce there's a lot of salt on the sidewalks, and we're trying to reduce the amount of salt that's used on the sidewalks.
Because that can have an impact.
That can have an impact, and there's liability issues for the university. But this is part of the collaboration, and the folks over in that department have been willing to contact the folks on the ground and and ask them to reduce the amount of salt application. So there is going to be some maintenance. We just put in the garden a few months ago. The trees just went in right before the winter. So the amount of maintenance that we're going to have to respond to the need as we see it. So there's going to take some maintenance, but we're not sure. Probably a limited amount, I suspect.
On the flip side of that, would you be doing anything to encourage growth, like adding fertilizer or other chemicals, or do you want to keep it as pristine as possible?
We want to treat everything the same and reduce the amount of, for example, limit or eliminate really the fertilizer that's applied, which would be different. So this is a landscape that's going to be treated differently than the rest of the landscapes on campus, the landscaping and lawns. So so we're asking for very little, no fertilizer, no manipulation, and so we're to allow the trees just to develop naturally without any help.
Some people might not be happy with that, depending on how it turns out.
Well, I think we have the university on board. I think they're also, the administration's very excited about the potential of the garden and how it's going to increase our capacity to teach some really important concepts to our student body, and the value of this place is just going to increase over time. So we need to take good care of it, because it's going to become more important, and the data we collect starting this summer is going to become more important as the experiment proceeds into the future, the longer it proceeds.
And as the climate changes and conditions change and plant life change, you would be, it seems to me, developing some very useful information to help people adapt to what the new environment is going to be.
Yeah, well, that's part of the idea, that it will provide an opportunity to see the potential effect of this changing climate on the health and vitality of our central New York ecosystems, and what climate change is doing to the important components of our local forests.
Coming up, we take a walk through these trees with the dendrologist who helped select them. Dr. Donald Leopold calls this landscape the most significant planting in the area, one that will provide a unique educational opportunity for students at both SU and ESF.
For many of the species that were selected for this experiment and this educational opportunity, the trees were picked to be either sort of on the northern limit of their range or maybe on their southern limit of their ranges. And so trees that should fairly readily respond to any kind of extraordinary changes in weather conditions, especially temperature and precip. So this is an example of a tree that historically was only found in southernmost New York. In fact, it was, I think, restricted to Long Island. It's called Virginia pine, Pinus virginiana. It's very common in the Appalachians, but it never really got north of Long Island. I think it's even wiped out of Long Island now, not because of climate, but because of urbanization. So this would be a really ideal candidate. If it is indeed getting warmer, then this tree should thrive at a much greater rate than a tree that is more northern in its distribution, because those northern species are really better adapted to much cooler conditions. So it's a very common pine throughout the Appalachians. It's regarded as an old field pine throughout the Appalachians, similar to the next species, which is the old field pine of New England, Pinus strobus, or eastern white pine. So the eastern white pine, Pinus strobus, is a very famous tree for many reasons, but it really was commonly invaded all kinds of old field settings throughout New England. And it's also one of the most important timber species in the northeastern United States. It was the reason why the Adirondacks probably drew the attention of loggers to begin with. A magnificent tree, nearly 200 feet tall, exceptional wood qualities, also a great ornamental tree. So the distribution of this tree is really more northeastern. It does go further south, but in the Appalachians, whereas you go further south In the mountains, you go to higher elevations, you get better conditions for a lot of species that have to have those cooler, more wet conditions. So in the Northeast, though, we would expect this tree, as it gets warmer, as it gets drier, to have less growth, to have lower growth than a tree that is more adapted to those warmer conditions. And so a lot of the studies that have typically been done have looked at these tree species, but growing where they grow. So the soils are different, the climate's different, everything's different. Here we've got them about 15 feet apart on the exact same soil, the exact same everything, so that we see differences in growth. And you have to tease them out carefully because you have to make sure you understand the growth of each tree species because it's different for each species. But once you go through that process, it's fairly easy to tease out differences in tree growth due to species differences because we've minimized all those other variations that are possible. The way that the climate is changing, there are two possible ways. One is that it's simply getting warmer, or that there's some other major variable that's easy to measure. It's wetter, or it's warmer, it's colder, or it's drier. And tree species will respond differently to those signals depending on where that species has really evolved over millions of years. But there's another way that the climate can change, which I think is the way that we're seeing very commonly, and that's the periodicity of extreme events is much greater, and how a tree will respond to that. So if you look at an average, the average precip might not be any different, but maybe it all comes in big events instead of more uniform. Maybe the temperatures aren't any colder or aren't any hotter, but we get much more extremes. We saw that last year, that we really had one of the most extreme springs in the history of upstate New York, where everything came out many, many weeks too early and then were damaged. And that would be really clearly reflected in the tree growth record. So how the trees will respond will depend greatly on the species and what the primary trigger or the driver is on that particular species. And so really these trees all represent a large number of hypotheses that students will be able to collect data on for many years ahead. And it may take 5 years, it may take 10 years to sort that out, or we might see some dramatic differences even sooner, but it all depends on what the climate is doing and how abrupt and what the magnitude of that change actually is. Typically, you don't find these tree species together. You find tree species that are from a certain region together, or maybe they're taxonomically related. But this selection of plants here was made trying to find species that are from their northern range limits, their southern range limits, or maybe they're from maritime climates that really require cool, moist conditions. They were very carefully picked, and some of these species are very common. Eastern white pine you can find in any nursery. I've challenged anyone to find a Virginia pine anywhere except for maybe a restoration nursery, because they're very impossible to find, because, you know, if you look at it, you might even regard it as maybe even on the ugly side. It's a very open, sprawling tree, but ecologically it's a very important tree. So this is an unusual collection because of the diversity of species and the fact that there are some species here that have never really been planted, to my knowledge, in central New York. So this is the Japanese hemlock, which from far away might look a lot like our eastern hemlock, and there are about 12 hemlocks in the world, 2 in the eastern United States. This one's slightly different. All the hemlocks have a small cone that's pendant, but this one's more rounded. I don't think I've ever seen this in central New York. Somebody might have it in a private backyard collection, but I've never seen it planted. I can't remember ever seeing it in any botanical garden or arboretum I've ever been at, so it's really a treat to see a tree that is very important in another country like Japan. But it's planted right next to a Carolina hemlock in this garden and an eastern hemlock, so we can look at how these 3 different hemlocks react differently or not to any kinds of changes in the climate that we might expect the next few decades. Hemlocks in general are a very finicky group of trees. They're typically found at high elevations, or they're found at, but not too high because they're not that cold hardy. They're typically found along streams, around lakes. They're found where their roots can penetrate sources of water below the surface. None of them are very drought tolerant, and so we know that eastern hemlock will do very well in the landscape of central New York. So we would expect all of these hemlocks, the Japanese hemlock, eastern hemlock, if that it indeed gets drier and indeed gets hotter, their growth will be reduced relative to species that are found further south and found in less protected types of landscape settings.
That's it for this edition of Improve Your World with SUNY ESF. Thanks for joining us, and we hope to see you again next time.